Now, finally, we're going to wrap this up and we're going to find probability using permutations and combinations. Okay, so now we're dealing with real life situations in terms of a state lottery. There are 48 balls numbered 1 through 48. They're placed in the machine and 6 are drawn at random. If the 6 numbers drawn match the numbers that a player had chosen, the player wins $1 million. In this lottery, again, so first thing you want to find, in this lottery, the order the numbers are drawn doesn't matter. Okay, so that tells me right there that phrase tells me this is a combination. Compute the probability that you win the $1 million prize if you purchase a single ticket. Okay, so first thing we want to do now, you've got to combine a couple different concepts. You've got probability, and then you've got permutations or counting principles, permutations and counting principles and combinations. So first thing with probability, we want to know, or theoretical probability, we want to know our total outcomes. So that's first piece we want to find. Okay, we know this is order doesn't matter, so this is a combination. Okay, so we're going to go 48, and we're going to choose, or NCR, they're only drawing 6. Okay, so 48, NCR 6. That looks like a G. All right. Use your technology and you end up with 12,271,512 total outcomes. Now, the desired outcome right? So there's only one potential way that you're going to hit that. So 1 out of 12,271,512. Right. Now, as a fractional answer, you can leave your answer like that. But in most cases, they will ask you to round your answer. So most calculators they can't handle that. So you will have to use a browser or Excel to actually get a decimal answer. But as a decimal, this answer is approximately 0.00000081. Okay, that's your answer. Most calculators will give you a scientific answer, which means the probability of you hitting this lottery and hitting all 6 numbers, or having all 6 numbers, irregardless of sequence, is extremely low. It's almost 0, which would imply you're better off spending your money somewhere else. And we'll see it demonstrated in this next example as well. So let's say, okay, we say, well, the lottery is not very good. My odds, or my probability of winning is almost 0. So let's think about, let's play poker, okay? So we've got a standard deck of cards, okay? And we want to find the probability of drawing 5 cards from that deck with a hand of 3 aces and 2 kings. So the first thing we want to do, we have to ask ourselves, does order matter? And the answer is no, because as long as you have those 5 cards, the order in which you have those cards doesn't matter. So we need to find our total outcomes. And again, this is theoretical probability. So in a standard deck of cards, you have 52 cards. and we're choosing 5. Okay, so that gives us 2,598,960 potential outcomes. Now, our desired outcome. So now it's going to bring in the fundamental counting principle as well. Desired outcome. You want 3 aces and 2 kings. And those are 2 distinct categories. So in a standard deck of cards, I have 4 aces, but I need for this particular hand, I need 3 of those guys. And we're going to multiply that by, again, a standard deck of cards. There are 4 kings, and we need to choose, or we need to have a hand with exactly 2. Okay, so you take your calculators, you can use parentheses, and you end up with 24. So you multiply that, you end up with 24 options as your desired outcome, or 20 ways to get your desired outcome. Okay, so now what we're going to do is we're going to find probability. So probability, again, is your desired outcome, or theoretical probability. It's your desired outcome, which is 24, divided by your total outcomes, or potential outcomes. So 2,598,960. Now, depending on what the question asks, you can have a simplified or a reduced fraction. So 1 over 108,290. That's a fractional form. So that's your fractional solution. Now, as a decimal, this is approximately 0.000000923. So again, you can use some sort of technology beyond a scientific calculator to find that decimal approximation, because most scientific calculators will give you a result that's in scientific notation. And then our final example, we're trying to create a jury. We have 27 people in the jury pool, 14 of which are men, 13 of which are women. We want to compute the probability that a randomly selected jury of 12 people is all men. Okay, now remember, it's randomly selected, so we're assuming no bias in jury selection. But that's not always the case. But for our purposes, on paper, we're going to assume it's randomly selected. Okay, so first question, does order matter? And again, the answer is no. So this implies a combination. So then you find your total outcomes, which you have 27 people. We're going to do NCR. And we need 12 of those people for our jury, which gives us 17,383,860 potential juror combinations. But our desired outcome, we want an all-male jury. So you have 14 males. Again, order doesn't matter, so N, C, R. and we want all 12 of those. We want 12 of those 14 to be on this jury. That's 91 potential outcomes. So then you find your probability. So probability of an all-male jury is 91 over 17,383,860. Now you can simplify this and you end up with 7 over 1,337,220. Okay, that's your fractional solution. But in most cases, they want you to express this probability as a decimal. So again, you may have to use a different type of technology if you're not used to converting scientific notation to decimal form, which is approximately 0.00000523. Okay. So again, it's almost, the probability of getting this all male jury is almost zero. Same thing with the playing card example. Okay, so that's how you apply counting principles to probability. I hope this helps.